I just start recording this lah. Because those who don't attend, just can send the recording, put it YouTube lah. Okay. So the RCD detects the difference between live and neutral. Okay. Because it normally right hand thumb rule lawan, because the thumb rule is like this. Okay. Right hand thumb rule. So it lawan jadi kosong. So in normal case, it is a zero current because they perfectly balance out each other. Okay. But in case the live is more than neutral, how can the live be more than neutral? Okay. Like a person touched the live. A person touched the live, so the current will go through his leg. Okay. Go through his leg and say maybe 1 amp. 1 amp go through his leg. So 10 amp, 9 amp. Okay, so that's how it is. So 10 amp go in to the house, 1 amp go into the through the hand and go to a person's leg, and 9 amp go back. Now there's a baki, 10 minus 9. Okay, so the purpose of the coil is to detect the baki, and if you detect a baki, it will trigger the RCD to trip. And for single phase, all single phase in Malaysia, the spec is 100 milliamp. If you can read on the thing, let me see if I have it. Don't have it right here. But if you look at the RCD, on it is written 100 milliamp. You go to your house, okay? If you go to your house RCD, if your house single phase, which is majority of Sarawak is single phase, you can see it's 100 amp written on it. Okay, that means 100 amp difference between live and neutral, and above, it will trip. Okay, 100 amp is a minimum. 100 milliamp, which is 0.1 amp. 100 milliamp is 0.1 amp. Okay, 0.1 amp. Okay, so for three phase you won't get until you reach charge band. Okay, yeah, both of you can take charge band because you got degree. If you got a degree, you can jump straight to charge band. Okay, you don't need to take a Wyman. But without degree, I think the minimum is diploma. Diploma in electrical, you can jump straight to charge band. But it's a good idea to take Wyman because I've been in the business for some time, I find most contractors get their contract from Semenanjung. Okay, the local Sarawak contract is not many, and maybe it's monopolized by a few people lah. That's why. Okay, so Semenanjung, how they look at it is, they look at the paper, the one who give you the contract. Ini cakap mak Wyman lah, you punya charge man lain lah. They don't know. See, those people who get the contract, they don't know. They read any Wyman lah, you punya charge man tak sama. Okay, so they won't give you the contract. So a lot of the contract requires Wyman. Okay, even though charge man is supposed to be higher than Wyman, those people who get the contract, they don't know. Okay, so if you really want to go to business, you really need to take the Wyman lah. Okay. Okay. So three phase, how does it work? Okay. Shit. So this is the three phase lah. Okay. So how it works is, I just give some figures. Okay, so it's maybe minus 3 amp, plus 2 amp, minus 1 amp. So you look at this, okay, the total is -3, -1, -4, -4, -2. Okay, you look at it. Okay, -3, -1, -4. Okay. Oh, okay. Someone requested to join, but I don't see him. Oh, okay. Okay. Okay, so you look at this, it's -3, -1 is -4. -4 plus 1 is... Oh, okay. -3 minus 1 is -4 plus 2 become -2. That is -2. Okay. So the going in through the three different phases, red, yellow, blue, is -4. Remember that is the amps. The volt is all the same, huh? The volt is all 240. Okay, the volt is all 240. Okay. So if this is -2, automatically this will be +2. Okay. So this is how it works. So this one total is -2, so this will be +2. So when you put a coil around all four, it's always 0. Okay. It can be a coil or it can be a clamp meter. Okay. Clamp meter, let me show you. Okay, so this is a clamp meter. So I went through a lot of these clamp meters already, but this is my one now lah. Okay, I think it's a higher model than this now. Okay, so you have this one also. You see, this is an extension, because this one sometimes you see like this one, how to put your clamp inside there, not enough space. So they have an extension. But the funny thing is, if you buy with extension, it's double the price. Yes, this extension is about same price as this thing. Okay, so you can put on all four, and this is a way in factories how they detect something is wrong. So they put on all four, and then let me see if I have something. No, I don't have it here. Okay, you put it on all four in a factory, and if you see a voltage, you see a current, then you know something is wrong in the factory. That means there's some leakage in the factory. So that's how they troubleshoot factory. Okay. Bobby, can you mute your... Bobby?
Yeah,
Bobby,
yeah.
Can you mute? Click mute.
Okay, okay.
Okay. Okay. Oh. You know which is mute, huh? The when you go down your screen, the first icon at the bottom of your at the bottom of the picture, you see the first icon. You just click that one. Oh. It is, you haven't got it. You see at the bottom of the picture, you see the few icons there. And then the second one look like a camera. The first one. You just click on that. Oh, okay. 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 So in a factory, they put around all four, and if there is a current, if there is a current, you can you know something. There's some leakage in the factory. Okay. Let me show you this. I have a picture of that. What one of the technicians showed me lah. Okay. Okay, so this is how they do in a factory. See, the red, yellow, blue, neutral, they put around all four. And if there is a reading above, I mean, in three phase, this is three phase, so 300 milliamp lah. Above 300 milliamp, something is wrong lah. Okay, so the three phase one, the spec is 300 milliamp. Okay, so three phase, 300 milliamp. So that's how it is lah. So for three phase is 300 milliamp. That means this three combined minus this one must be 300 milliamp. Then only this thing will detect. I mean will trigger. Okay, this call will trigger. See, so single phase is 100 milliamp and three phase 300 milliamp. So you must know this for the exam. The numbers 300 and 100. Okay, and if they ask you about RCD, you must write the number also. If not complete answer. Okay, so three phase is 300 or 0.3, which is the difference between these three plus minus. Why is there plus or minus? Because AC sometimes plus, sometimes minus. Okay, because the curve is like that, right? So sometimes it's below the zero, sometimes above the zero. So that's why you got plus and minus. Okay, so you must add all three plus this one, and if it is more than 300 milliamp, this will trigger. But so far in the exam, I haven't seen them asking to describe the three-phase RCD lah. But you never know lah. I mean, Cisco is standard lah. Their exam never have three-phase, but nowadays it's no more Cisco. The judgment exam is Cisco don't give anymore. They only give above judgment L1. That means L2, L3, L4, all this lah. Okay, H1, H2, H3. Cisco still give. But Wyman G2, G1, and judgment L1, Cisco don't give anymore. Like me, I took all in Cisco. All my exam, I think 5 exams, all in Cisco. But Cisco don't give them anymore. They subcon out to other contractors, which is, I mean, the Cisco training school don't like it lah. What to do? I met the teachers during that time when they subcon all the exam out. And the teachers were very angry. They lose their. I mean, less work for them, but they still didn't like it lah. Okay. But I mean, for me also, I feel they should not subcon out like that lah, because it's very obvious the Cisco people have more knowledge lah. Because they are working on this day in, day out. Obviously, they are better than outsiders. Sometimes half half. Outside companies, they go and get a lecturer who is not really into electrical. Sometimes they are electronic degree, and teaching electrical sometimes quite bad lah. Okay, I've seen sometimes. Okay, so that's the history of the exam lah. Yeah, so now you want to take the exam, you can go to ILP, ABM. My students mostly go to ABM lah. Okay. And then there's a few other schools lah. Okay. Yeah, Bernard School, this lah. Okay. Okay. ABM is free, but I mean the course is free, but the exam you have to pay. Okay, the exam you have to pay. Last time my student took from them is about 550 like that lah, 550. Okay, but the course is free. Okay. Okay, so I hope you understand this. This is a 100% question lah. Mostly they are single phase lah. Okay, but you never know, the three phase might come also. Okay, so this is very important concept to know lah. And this also how they check for faults in factories. Especially factories are almost can say 100% of factories are three phase lah. Yeah, why you need three phase and single phase? Three phase you can get more power. So factory need more power, so use three phase. Low power like house, single phase. But for big power like factory, you need three phase. Yeah. It's just like three wires going in versus one wire. That's the only difference lah. Yeah. So they call three phase 415. Why they call it 415? A lot of people don't know this. 415 is 240 times root 3. So it is not 415 volts. Single three phase house also the wire in the socket point is still 240. Yeah. There's I met one guy quite advanced in electrical, but still three phase should be 415 mana boleh. Nanti you punya alat semua hangus lah if your socket point is giving 415. Your socket point is still 240. But how it works is, okay, you got three phase house. This room will be red, another room will be blue, another room maybe front hall will be yellow. Okay, so they separate the wires. So it's quite dangerous in three phase house if you start doing your own wiring and then from this room I take one wire and then pull another wire from that side also join. It'll be a big explosion. Okay, so three phase house is a bit dangerous to do wiring unless you understand it properly. Okay, you don't go and join one room wiring to another room wiring, because the three phase red and yellow join is very big noise. Okay, and is a lot of damage. I've seen this because in my school we sometimes conduct lab, and then when red and yellow join, the sound is very big. Okay, the sound very big and damage also very big. Normally the Cisco cutout fuse will blow. Okay, okay, I tell you the difference in sound so you know the danger. In the lab, if single phase short, that means live neutral short. One guy will be here, next guy next door only. The other guy, next door guy don't know this guy made a shot. Okay, but light red yellow or yellow blue touch. My room is about 60 by 30. Yeah, the whole is 3 rooms. I split into 3 rooms. All 3 rooms can hear. Even down, because mine is 1 level up, down the stairs also can hear. Okay, so you see the sound difference is so much different. So you can imagine the danger is also like that lah. Okay, so I haven't touched 415. I hope I don't lah, because I don't think a human can survive 415. Okay, unless you're very lucky lah. Because from the sound you can tell it's very much more powerful. But the worst case scenario is one guy in Cisco touch about so many kV, about 20 over kV. Okay, his name is Slamat Wong. Justine might know Slamat Wong. Okay, he is quite high up in Cisco now, SEB. Okay, his name is very correct lah. Actually, he's Chinese, but a Malay Bomo saved his life when he was a baby. So the father named him Selamat Wong. Okay, and then he went to Cisco and worked, and he got a 20 kV shock and still survived. So dua kali Selamat Wong. Okay. Okay, so so at least you know the danger lah. Know the danger of 1.5. From the sound, you know it is very dangerous. I've touched 240 probably 200, 300 times. Okay, 240 so many times, even on my head, the worst case. You know, when you, there might be one question in the exam, where's the most dangerous part of your body to touch electrical? It's the head and the heart, okay? These 2 points you must keep away from electrical as far as possible. Yeah, so I was doing one work a few months back, and I made a temporary joint with, just go long wire like that. And then I was climbing up my steps and I forgot the wire touched my head. So that was the first time in my life I touched the head. Okay. So that's what you must know lah. And then it takes 40 volt and above, okay, to go inside your skin. 40 volts and above. Because your skin got resistance. So you must have 40 volts and above to go inside your skin. Okay. Okay. To go inside your skin, you need 40 volts and above. Okay. That's why they call below 50. They call it ELV. Okay. ELV, extra low voltage. Okay, below 50 volts. Okay, so anything to do with telecom, CCTV, they call it ELV. Okay, no, where you can touch anything live also can. Okay. The worst case is that I've known is press metal bintulu. The wire coming in is a huge aluminium. Okay, that's the wire coming in. So my Cisco friend touched that one live. It's not covered. He touched it live. Okay. So he didn't die. Okay. That factory is using 1/3 of Sarawak's power, and he touched the incoming wire. Okay, and he didn't die. Okay. So that's because the voltage is below 40. Okay. So the voltage is below 40, that's why you can touch. So these are some of the dangers you must know. Okay. So you see, power is VI. E equal to VI. So the power going into that press metal factory is very, very huge. But the voltage is below 40. But the amp is very high. That's how they can get the power. Okay. Because the press metal factory use more of the amp rather than the V. Okay. Okay. Because they need to electrolyze the aluminium, so they use the I, not the V. Okay. So the V is the force to push the electrons, and the I is the speed of electrons. Okay. So the I is the real, you can say the real thing is the I. The V is the thing to push it. Okay. So the thing to do the work is the I, and the press metal need a lot of I to electrolyze the aluminium. Okay. So these are fundamental things you need to know for safety. And then another thing, wire size. Okay. Wire size only depend on I. Okay. So wire size, any wire size is related to exactly how many I you can carry. Okay. So wire size only depend on I, not the V. Okay. So that's why the overhead line, the big grid line, is very high voltage, but very low I. That's why it's quite small. It's only about this small. Okay. Only about this small. It's carrying the whole power of Sarawak, just this small only. Okay. So I seen it. I held it in my hand. It's just about but that small lah. But that small. Okay. So and even that small, it's not using the whole. It's not using the whole this big. Okay. The center of this is steel because they use aluminium. Aluminium is very brittle and can break. Okay. So the center of it they put steel wire. Okay. Like dawai lah. Okay, but very thick dawai. So in the center is all steel and only the outside is aluminum. Why is that? Because in AC, electron don't use the whole conductor. They use only the outside. Okay. How is that happening? You see, in AC, say you have a wire. Say you have a wire. The current is going back and forth. Current is going back and forth. Okay. So you imagine like this, it's going back and forth. Okay. So say one electron going back and forth. So here you got 10 field line. You know the magnet, electrons are magnets. Okay. So the magnet, like the Chegu in the primary form 1, form 2, they put a magnet here and then you can see the field lines. Okay. So say here you got 10 field lines. Because this is a turning point. Just like you throw a stone up, the speed of the stone at the top is 0. Okay. So this is 0 speed. 0 speed, you got just 10 field lines only. Okay. And then here also 10 field lines. But here is moving, maximum speed is here. Okay. So say assume it is slow lah. T plus 1 is 10. T plus 2 is 10. T plus 3 is 10. I mean, here is a lot of field lines. A lot of field lines here, 10 and 10. So now you got a varying field density. Here low, very high, and low. Okay. So this FBI rule, you must put like a gun first, then you become FBI. F in form 1, form 2, they teach you this one is force. So that means if you move like this, you get a current this way. But I prefer to call this varying field density. That's why I wrote my book. That's my book. Okay. The whole book I don't call it force. Okay, I call this varying field density. Okay. That means here 10, here a lot, and here 10, that's varying field. So you got varying field already. You got varying field, you got magnet, electrons are magnet, you got current generation. So what happened here? You see, say one electron is this way, so it generate current this way. Another electron this way, north south that way. This is north south. So like that, another one like that. So from the center of the wire, it is generating current outside. So it's pushing all the Bakun electron to the outside. So it doesn't use the center. Okay, so the word they call this is skin effect. Okay, this is called skin effect, which only happens in AC. Because only AC you got electron moving back and forth. In DC, what happened? DC is going straight, right? So if it's a big power, you got a lot of field lines. Okay, you got a lot of magnetic field lines, but it's not changing. So you don't have this one. Because there's no varying field density. So you don't have this one, you don't have this one. Okay? So you can have a lot of field lines. As long as it's not varying, you don't get a generation of current. So in AC, you get a generation of current from the center is going out. You don't like it. You don't want it, but it happens. So what they do is they know that there's nothing flowing in the center. So they put steel because aluminum is quite not so strong. Okay, so they put steel in the center. So the span length of the towers can be further, you see, because steel is stronger. So you can put it the span, because one tower, I heard even 2 towers cost a few million. Okay, 275 kV towers. 2 of them cost a few million. Okay, so if you can put it further, of course, saving for the Cisco lah. Okay. Okay. Okay, so okay, so okay, let's go through some of the exam questions again lah. The second exam. Last time we went through one exam. Now we go through another exam. Okay. Okay. Okay, these are Cisco exams. Okay, assuming other factors remain constant, the length of conductor half, the resistance will be, okay, this is the only formula you learn in, at least when I went to school, I didn't learn V equal IR. See, P equal V equal IR are the two main formulas you use in electrical, V equal IR and P equal VI. This is called Ohm's law. Okay. Okay, this is called Ohm's law. Okay. V equal IR and P equal VI. Memang pakai lah, some formulas, a lot of formulas you don't use in industry, but these two you have to use. If not, you cannot do even basic electrical. Okay. V equal IR and P equal VI. Okay. So, but funny thing is, my whole form school, I didn't learn V equal IR. The only formula electrical that I learned in Form 1, Form 2 is this is the only formula I learned in Form 1, Form 2 for electrical. I didn't learn regular IR. Okay. So it's rho L over A. And sometimes Cisco exam they ask about this formula. And this just like just now, that question is asking about this one, which is the only electrical formula you learn in form school. Okay. So what is it? Rho is okay. Rho is the resistivity, L is the length, and A is the area. Okay. So this formula you must know. Okay, because it's every secondary school student I taught this one in, I think, Form 1, Form 2 like that. Okay. I think maybe now they teach V equal IR. Not sure, but when I went to school, I only learned this one. So that's why in the Cisco exam, quite often I see this question coming out, this formula. Okay. So what did they ask? So the length is half. Okay. Okay. So the length is half. So the resistance will be half also. You can see from this. Okay. If this is half, this will be half also. Okay. Okay. So that's the answer lah. Okay. So you look at this. So half the initial value. Okay, that's the answer. Okay. When conducting an insulation resistance test, okay, just like Justine, I was telling you, you see, the word is not mega, it is insulation resistance. Okay. the meter is called insulation resistor. Insulation tester. So what is insulation? Sometimes they ask you that question also. What is insulation tester? So you must draw. I went to EIU, and they keep telling me to tell my students, draw paling banyak. Okay, draw as much as you can. Okay, so sometimes you know the answer, but you don't know how to write properly, so you get wrong. Okay, so that's why they told me to tell all the students to draw as much as possible. Okay, so when they ask what's the meaning of insulation resistance, you draw like this. First, you just draw a rectangle and then make it into 2 wires. Then make it 2 wires. Okay. Then you draw meter. Okay. This is a meter. Okay. Okay. So you just write down insulation tester. Okay, like just now you're saying it's mega. Actually, most people call it mega because in the old days, we always use a British brand of insulation tester, and that brand is called Mega. Okay, it's a British company. Okay, they still make this. That company still make this thing. I can tell you the difference in price. You see, Cisco got a list of meters that they approve. Okay, you cannot buy any meter. If you want to do official Cisco measurement, you must use a certain list within their spec. Okay, that means they have a list lah, approved meters. Okay, so I asked Cisco why they recommend Kyoritsu. Kyoritsu is a Japan brand, right? Why they recommend that one? They said they don't recommend that one. It happened to be in the list of Cisco, and it's the cheapest, which is good. That's why all of Sarawak electrical contractors use Kyoritsu. Okay, because they know Cisco approve it. So word of mouth, okay lah, ini paling murah. So everyone buy Kyoritsu. I think 100% of Cisco contractor in Sarawak use Kyoritsu. But in the old days, insulation tester was always Mega brand. Okay. So Cisco, when I went for the training in Cisco, they use a Mega brand, 12,000 for the insulation tester. The one that I have is 550. I bought it before the ringgit went down. So I bought mine for 550. Okay. But the Cisco one is 12,000. So you can see the difference in price. Okay. ABM Kuching, they got a mega injection tester. Injection tester, which is okay. I bought mine from India for 20,000. So theirs is, if even normal British brand is already expensive, this is top British brand. Oh yo, can I imagine the price lah? Okay, so the injection tester is that one also come out in exam. Maybe after this I'll talk about that one. Okay, injection tester quite frequently come out in exam. Okay, so this one is not complete. You must draw like this. You must draw this dotted line here. Okay, what does it mean? You are checking this plastic. Is it good? That's the meaning of insulation. The plastic is called insulation. Okay. Some Cisco people, they don't want to call it plastic. They call it insulation. The insulation is spoiled already. Okay. The plastic can be different kind of plastic. It can be rubber also. Gerta Malaysia was the original covering of the wires. Okay. In the beginning of electricity. The British call it Gerta Picah. They actually use the Malay word Gerta Picah. I don't know why Picah. The Gerta Picah. But that's the actual word the English and Americans use in the old days. Okay, Gerta Picah. Yeah, so they actually use rubber, and then they found out that there's a problem with that one because it's natural from the rubber tree, right? So ants and all this will start eating it. Okay, so that's what I heard in American houses. Some of the old house, you go up the roof, all bare, all eaten up, 100%. Okay, so that's why they start using many different material, and finally nowadays there's only two material, PVC and XLPE. That one also you must know. Okay, PVC and XLPE. So now the world has standardized to these two plastic. Yeah, there were a lot of different plastic used. Okay, paper was used also quite a lot. Paper, okay, kertas paper. Okay, but now it's only these two plastic. Okay. Uh, okay. So anytime you see the word describe insulation tester, you just draw this one lah. You draw already, you get most of the mark already, and then you just say lah to detect the plastic, the insulation strength of the plastic. Okay, that's why it's insulation tester. Okay. 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 Let me jump to this one I told you, the injection tester. Okay, because that one is quite frequently come up in judgment exam. Okay. Okay. This is the main switchboard. I show you the whole main switchboard first. Okay. This is a whole main switchboard. Okay. So this is a whole main switchboard. So what's a main switchboard? In the house you got DB, distribution board, right? Okay. What else do they call it? DB. No, there are some people use other words for DB, but main switch, something like that lah. But I think DB is a more correct word lah. Okay, distribution board. Okay. So the house you got DB. Building, a bit bigger building or factory, they use this one. Okay, main switchboard. And then for the grid, like Cisco grid or Sarawak substation. So all three does the same thing. Okay, you got the DB. Okay, you got the DB, main switchboard, and the substation. They are the same function, protection. The function is protection. Okay, DB, main switchboard. Okay, so all three of these have the function of protection. Okay, so the house one, not so complicated. Okay, main switchboard, bit more complicated. Substation, you get the very highest end high tech stuff inside there, the latest computer technology, fiber optic, all the very latest thing inside there. Okay, okay. So main switchboard is for building. Okay, how do you differentiate it? 0 to 100 M dB. Okay, what's the limit for main switchboard? Must be very huge lah. This I mean, I haven't seen the figure for main switchboard, the maximum limit for main switchboard, but I think something like that. Okay. So, but definitely you must know this one: 0 to 100 M only dB. Okay. Above 100 M you must use MSB. Okay. Greater than 100 M you must use MSB. So I just assume 10,000 M. By not be M, it might be in power rating. Okay. Okay, because the M will still be low, because if they use such a high M, the wire too big. Okay. 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 So just to give you an idea of the wire size, all power station generate at around 11 kV. Okay. So in Sarawak, you got Bakun, Murum, Muka, Miri, okay, Balingian. They're all around 11 kV. Okay. Power station. Okay. All power station generate around 11 kV. Okay, around 11 kV. Plus minus a bit lah, sometimes up to 15 kV, sometimes, but mostly it's 11 kV. Okay. So you can see my friend took a picture of the Bakun and he sent it to me, so I show you. This far. Okay, I show you the picture of the Bakun. You look at this. This is 11 kV. Okay, and this 275 kV. See, this one my friend took from the top of the dam. So you can imagine from the top of the dam it looks a bit small, but this should be huge. Okay, I don't think you can put your hand around this one. Okay, a human hand cannot go around this one. I'm sure of it. You look at the wires, how big they are. It's 11 kV. 275, look at it. You can barely see a dash of line here. Okay, so because they use a transformer, the wire is so small. If not, this wire had to go all over Sarawak. Imagine that. This is a huge wire. The towers must be super strong to hold this kind of wire. Okay, and the price will be too high, and most people cannot get electricity because of this. So it's all because of Tesla that we have this system of using a transformer. Okay, 11 kV, very big wire. 275, very small wire. Why is that? Because P equal to VI. Okay. Okay. It's all because of P equal to VI. Okay. Because P equal to VI, you put this one very high, this one will come very low. But wire size depend only on the I. So when the I is very low, you can have very small wire. Okay. Understand? Huh? So this is very important to understand. You can put either this up or this one down, or the other way around, using a transformer. So this whole idea came up by Tesla. That's how we got our whole electric system. Okay. Before Tesla, how the system? You have one generator. Okay. supply one housing estate. That's it. Further one housing estate, voltage drop. Okay, the bulb not enough power, cannot light up. Okay, because voltage drop when you go too far away from the power station. Yeah. So maximum in Edison's time, Thomas Edison's time was about one mile a bit, 1.6 kilometer. Okay, one generator, 1.6 kilometer maximum. Okay, beyond that you need another generator. Okay, so when Tesla come out with this AC idea and using transformer, you can power station in Bakun, and we are here in Kuching, a few thousand kilometers away. Okay, so the transformer enabled this far distance traveling of power. Okay, it's just because of transformer. Okay? If not, the wire will be too big. So why Bakun produce 11 kV? Why don't Bakun produce a 275 kV? Actually, it's cheaper. If you produce a 275 kV, if you can do it because everything will be very small. The whole Bakun will be very small. All the generator will be very small because the wires can be very small when they produce a 275. But there might be a problem because arcing. 275 can jump. See? Can jump from one coil to another, and then there'll be a big problem. A second thing is a human cannot work inside there. Okay? There's too much 275 kV inside the Bakun, and then the humans cannot walk around. Okay? So there are two issues. That's why you cannot produce at 275. You must produce at 11, which is the power coming into the voltage coming into your housing estate. Every housing estate got one substation that coming in is always 11. Okay, so the going out of Bakun is 11. That's why the wires are so huge, because the amp is so high. Okay, the amp is so high because the V is only 11. So the transformer do put this one very high and this one go down. This one remain the same. Okay, understand? Huh? This one they put it very high. This one will go down. So in the Sarawak grid, okay, in the Sarawak grid, it's only about not 50. Sorry, 10. I remember the number now. It's 10. The grid, that means the 275 kV grid. The amp is only between 10 to 75 amps. Okay, that's the only amp that you have in the big wires, the 275 kV wires. Okay, so that's why they can use very small wires. Okay, how small is 75? When you start your car, you crank your car, it's more than 70 volts. More than 70 amps. Okay, I tried already. Actually, my son's Kancil, not Kancil, what was it? Viva. Not Viva, was it? The new one. I forgot. I forget it. I started and it was about 100 plus amps. The cranking amp of a car is 100 amps, which is more than the biggest wire in Sarawak. The 275 kV wire is only between 10 to 75 amps. Okay. So that's why when you jump your car, if your cable is not big enough size, you cannot jump. Which is the case in most, if you buy from a supermarket jumper, most of them cannot work. I already tried. Okay, so you don't try if you haven't bought. So if you want to make a jumper, you better make yourself. You buy a 25mm welding wire. You go to some hardware, they sell welding wire, and you make yourself. You can make how long you want. So I bought one in 1995. Those days they make ori one, so it can jump. Even now I still have it, very lasting also. After that, the suppliers, they start cheating here and there, and then they put very small copper. The wire very big, plastic besar. Okay, about this big lah. Okay, the plastic, but wire inside so tiny inside. That's why the jumpers cannot work. Okay. So the only way is to buy welding wire. Some shops sell welding wire. So they sell it, I think 25 is the minimum welding wire, 25mm square. 75 square. You buy those wires and you make jumper. Make yourself. You buy the crocodile clip yourself. Okay. Okay. Yeah, actually, I recently one of my neighbor here is quite a big shot. He got a big car. Cannot jump. So, yeah, of course. I went there after a long time. They try. Of course, lah. You buy from hardware store nowadays. The super safe one cannot work one. No one. You must make yourself. So I sold him lah. I sold him for 100 180 ringgit. But my son, he was my son's friend, so my son said no, cannot sell him so much. My friend, okay lah, reduce half the price. Okay, so yeah, that. Okay. 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 So let me get back to the injection test, which is a very common question in exam. Okay. So you know the difference between the DB, MSB, and substation is a small power, higher power, and super high power. The substation means the Cisco one. Okay. So the limit for using MSB is greater than 100 amp must use MSB. Up to 100 amp you can use DB. Okay. So you must know that lah. In case okay. Abdul Razak, you handle all the big buildings. You must know like if the building is more than 100 amp, they're using DB, it is actually wrong. Wrong means, you see, you might say, yeah, wrong, tapi masih jalan. The problem comes when you are insurance, okay? Yeah, if more than 100, yeah, you say yours is more than 100 amp, so it comes, a problem comes when insurance, in case there's a fire, and then you're using DB, this one didn't follow spec. Insurance, they'll find ways to not pay you. This one didn't follow spec. This is more than 100 amp and you're using DB. You should be using MSB. Okay, so that's where they can find a way not to pay you, because insurance, the staff of the insurance company is find ways not to pay you. See, that's their job. Okay, so I seen problems like this lah. Like MSB also need a certified person to come and check every 2 years. Okay, if you didn't check, the problem comes during a fire. They say this one not calibrated by the tester. Okay, so they don't want to pay you because you didn't follow the procedure. You see, these are all procedures. I'm talking about big money. I heard one. I think ILP Kuching. They had to spend extra 20,000 because they didn't calibrate, and then the bomba came. And the chief told me something like that. They had to spend extra 20,000 because they didn't calibrate in time, and then bomba audit came and they failed because the calibration was out of date. Okay, calibration of MSB was out of date, so they spend. He told me that 24,000, something like that. Okay, so you fail your bomba audit if you don't calibrate it. You must use MSB one thing, and then you must audit every 2 years. Okay. You must call a special auditor. I can do it. I have. I don't know that. Legally, I can get the certification to do this, because according to the spec, you must have IR and then competent engineer, which I have everything. Now I go to EIU and say, hey, sama buat ini. Okay, you have to buy this injection tester. So I bought 20,000 injection tester, and then I wait now already 7 years, 8 years already. I still haven't got the approval, but luckily there's a Abang FND, almost Cisco engineer, who has this license, and then he let me use for free. Wow, so I can do it lah. Okay, he let me use his license for free. Okay, so okay. Okay. So let me go back to this main switchboard. Okay, let me get back to the spec. Single phase is up to 50 amps. Let me show you the spec better. Okay, this is a spec. 52 amps. 52 amps is one phase. Okay, single phase. More than 52, you must use three phase. Okay. And then beyond that, you must use MSP. So all these, I know people have pushed, even I've seen people using 80 amp single phase. I've seen myself. I mean, they asked me to repair something, so I seen it lah. Okay. So, but the problem comes when there's a fire. Okay, and the insurance don't want to pay you because of this kind of issues, because they didn't follow this spec. Okay. So this under the red column here is the spec lah. In fact, this page is very important. If you want, you can print screen this one. A lot of data here that you need for your exam. Okay. So Cisco change it. The EIU is still 5 kilowatt per single phase, but the ordinance means the law lah. Okay. But Cisco changed it to 10 kilowatt without the law changing. So that means single phase 10 kilowatt, which is 52 amps. Okay. More than that is you need three phase. And beyond 100 must be MSP. Okay. And beyond MSP must be substation. But normally substation, not only Cisco, of course, in most cases, Cisco only handle. But in all pump estate, the MSP, the substation is handled by the all pump people. Okay. So that's the only case where a very big equipment is handled by the company itself, non-Cisco. Okay. All pump and very big factory also, like Press Metal has its own substation. Okay. So very big factory also has substations. Okay. Okay, so let me get back to the injection test. Yeah. Okay. Okay, this is what you have to do. Okay. So basically the bar, I think hard to describe this without telling you the circuit of the main switchboard. So let me show you the circuit. The circuit also guarantee come out one. Okay, this is a circuit of, but actually you have to memorize minimum. You have to memorize this, so you can take a print screen of this one. Okay, anytime you see the word MSB come out in your exam, just draw this one only. So how do you memorize this one? You see, this is the bar. Okay, but they didn't draw all the bar. There should be 1 bar, 2 bar, 3 bar, 4 bar. Okay, but they just draw 1 bar, and this one is the coil. So this coil is this one. You see this coil? 1, 2, 3, 4. This coil are called CT, current transformers. Okay, so the thick one are called protection CT. Okay, protection CT. The thin one is measuring CT. Okay, the thin one is to give reading to the ammeter. Okay, so you got the protection CT, the thick one, and then the measuring CT, the thin one. And here you got one extra. The one extra is to give signal to the other brain. Because in the main switchboard, you got capacitor bank. That's the only difference. The biggest difference between main switchboard and DB is they have a capacitor bank. Okay. So they have a lot of capacitors in main switchboard. to balance out your coils in your factory, because your factory mostly using motor using coil. Okay, so the capacitor bank will balance out the coils. Okay, why is that? Because you see, in AC is wave, right? Okay, you got V and I. It should follow the same. V and I should move together. Okay, but when it gets into a coil, the current is behind. This is the current. The current is behind the voltage. When you get the capacitor, the current is ahead of the voltage. This happened. This is a problem. So we need to find a solution. What is the solution? Most of human using coil. Motors are all coil. They use coil to do all the work. Okay. So in most cases, the current is behind. Okay. So you need capacitor to push it back, because Cisco want it together. Okay. So the measurement of this movement is called power factor. Okay. Okay. The movement of the V and I is defined by this word power factor. Okay. And the power factor limit for Cisco is this one, 0.85 to 1. Okay. It cannot go more than 1, because the curve is a cosine curve, which is okay. So when it is inductive, it goes down here. When capacitive, it goes down here. Yeah. But Cisco don't care, go down here or go down here. Both define you. That means Cisco is 0.85. Yeah. Okay. So it's 0.85 Cisco limit. You go down here, you get fine. You go down here, you get fine. So why would it go down here? You use too much capacitor. I have one case. See, there's a building in Kuching. The Sandra Padang building is a very old building. One of the oldest tall building in Kuching. Okay. So the capacitor is energized manually. Okay. And then this guy who is in charge, he said, hey, I buy very expensive capacitor, so many expensive capacitor I put there, still always out, always Cisco find us. Why? You cannot put too much capacitor. Must be exactly right. You put expensive capacitor too much, it goes down here. Cisco don't care. You put too much, also they find you. Too little, they find you. Too much, also they find you. Okay? So must be exactly right. So nowadays it's all automatic. Okay? So they use a brain in the capacitor bank. There's one portion of the switchboard is called a capacitor bank. Okay? So let me show you. Okay, so this portion of the main switchboard is called a capacitor bank, and this is the brain of the capacitor bank. Okay, so that brain get a signal from that extra CT. Okay, you see here, I told you red, yellow, blue is to measure the current in the bars, right? But I got one extra here. That extra one gives signal to the brain of the capacitor bank to kick in more capacitor. Okay, it automatically kick in. You don't need a human to on more and more capacitor. Okay, the brain will tell you to do so. Okay, so this one is basically the bar. You can see the bar here. 1, 2, 3, 4 bars. Okay, so they draw only one bar. There should be 4 bars here. Okay, so this is a CT. This represents the CT. So this is the black CT here. The thicker one. The thicker one I call a protection CT. So these are the protection CTs. Okay. So the red, yellow, blue CT go to 3 different OC. This is the old days. In the old days, you go to 3 different OC. Okay. Now they make the 3 into 1. Okay, they use electronic to make the 3 into 1. When old days always 3, but you cannot say nowadays only modern. No, when you work in industry, you see some of the old one also, because the old one tend to be very reliable, can last 50 years, 60 years also can. Okay, so in the old days, they go to 3 different. Okay, because in the old days, you know, like if you go in the industry for so long like me, the oldest thing tend to work better. Okay, so it's not necessarily the new thing is better. In fact, a lot of new things are designed to fail. Okay, most of the new things cannot last. Okay, the old days they make things to last 50, 60, 70 years. Nowadays they see that one cannot make profit, so they make everything purposely to fail. Okay, I was in Western Digital. The CEO from US came. Yeah, I think I need to put some defect in the disc. If not last too long, hard disk. So people don't want to buy new hard disk, so business affected. So they purposely put some defect inside there. Okay, so this is how industry works, lah. Okay, and now it's more and more that way, such that most of the things cannot last long. Okay, okay. So this is how this thing works. So red, yellow, blue, neutral. The red, yellow, blues. CT. What is this S1, S2? You look at here. You can see this one's name is S1 and S2. The two terminals. The two terminals are S1, S2. Okay. So if you look here, the S1 of red, yellow, blue go to the 3 different OCs. Coming out of OC, they're coiled up. They're coiled up and joined to the neutral S1. Okay. So by right, just like just now I show you, if you put on all 4, is 0 volts. 0 amps. The resultant will be 0 amps. So there'll be 0 here. And this 0 goes into the fault relay, okay, and come out. Over here is all green wire. Yeah, that's why I put green wire here. So you can see this from here. You see, at all the other terminal, all green wire. All green wire. Okay, that is this one coming out of this one. So anytime you see main switchboard come out in your exam, just draw this one. Okay, this is from 1980s till now. It's the same. Okay, you see MSB, just draw this one. Okay, because I know someone who took the exam in 1980s, and he said he had to draw this one. Okay, okay. So this is a thing lah. Okay, so how does it work? The 2 brains of the MSB are the OC and the effort. These 2 will use a signal wire. They are looped together and come to this one, shunt trip coil. Okay, shunt trip coil is a small little coil which is quite powerful for the main breaker. Okay, the main breaker could be a big 70,000 ringgit breaker. Okay, so how does it work? Is it's just like, you have a spring, very powerful spring, which is compressed, and then it's just held like this, a small little thing holding it. Okay, it's very powerful. You let go, boom. That's how it works. Okay, so that the wire to energize this plunger is a coil lah. It's called a shunt trip coil, and the wire going into the shunt trip coil to energize the shunt trip coil is called shunt trip wire. Okay, so that's how. If you look at this one, so this one, you see this wire here is called a shunt trip wire. This wire is shunt trip wire, and going to this about 70,000 ringgit breaker. Okay, I say 70,000 because I'm estimating, because one of my students bought it about 10 years ago for about maybe 30 to 40,000. So I estimate ringgit go down, everything. I estimate should be about 70,000 now lah. Okay, so so this is the main breaker for the whole building. It's called ACB, A circuit breaker. Okay, so that's how this circuit works. Okay, the red, yellow, blue will go to the OC. OC come out, look together, join to the the S1 of the neutral CT, all go to earth fault relay. This is OC relay and earth fault relay. Other side of the earth fault relay, all green wire. So all green wire going to the other side of all the coil, all the CTs have green wire. Okay, the earthing wire. Okay. And then this one you see joined to this one is for the voltmeter. Joined directly to the bar is voltmeter. Okay. So current, you measure current using a coil, not touching the wire, but measure voltage directly joined to the wire. Okay. Remember that voltmeter, that's also one question I see in the Cisco exam. Voltmeter is noted to have very high ohm. Okay. And ammeter is very low ohm. In fact, the perfect voltmeter is the highest possible ohm meter. Okay, that means it's very high ohms inside there. That means resistance very high. Okay, and the perfect ammeter is the one of the lowest possible amp. Okay. So these things are expensive. The very high end ones. Okay, they sell it in the market. That can measure super like clamp meter that can measure even the mouse. I've seen even the mouse wire it can measure. Okay, most clamp meter cannot measure the mouse wire current, but I've seen it's from England, 1,500 pounds can measure even the current inside the mouse wire. Okay, so when you go to very high end meters, the price is terribly expensive. Okay. Okay. There is a ohm meter to measure. Why they need super high end ohm meter? You see, when they do you see the just now I show you the bars, right? Their bars when they join together, they have a bolt, right? But maybe it's not tight enough, so they use very high. They can measure micro ohms, a meter that can measure micro ohms. They put on the tool. They see the micro ohm is good enough. Okay, pass. That means the bolt is tight enough. But a poor electrician just tighten all the bolts lah. Okay, the poor electrician tighten all the bolts. You need to buy that super expensive, about 20 over 1,000 ringgit ohm meter. Okay, you just tighten all the bolts. Okay. So this schematic, I think you take a print screen. Guarantee you must draw it for your exam. Yeah, you must print screen of this. You must draw this for your exam. Since 1980s till now. Okay. So the shunt trip coil, you see the OC and the earth fault will give signal to the shunt trip coil, and that will trip the main breaker. That means trip the incoming supply. Okay, and this side here is the outgoing. Okay, MCCP outgoing to your DB, all the different DBs in the building. Okay, so this, once you understand this one, then only I can explain the injection test, which is favorite question in Cisco exam. Okay, so what the Cisco exam injection test is? Okay, I want to see if this system is working. Is this system working? That's what you have to do once every 2 years. You have to call the guy to do it, because it's not any guy can do it. You must have a license to do this. Like I told you, I haven't got a license to do it, even though I'm qualified for it. It's some politics now. They don't want to give me. Okay, so I use Abang Effendi's license, so I can do it because I'm using somebody else's license. Okay. What they do, they want to confirm this circuit is working. That if this circuit not working, your building will burn. You see, that's why they require you to test this circuit once in 2 years. Maybe some of this equipment here not working properly. Okay, then something wrong, your building will burn. Okay, that's why the law says you must test this circuit once in 2 years. So how do you test it? Okay, you must off Cisco supply. Okay, you off Cisco supply. How they do that is if this ACB, you have to use a spanner, the spanner that goes into the hole there and turn it until you can say test. Okay, there's energize and test. Okay, so the test means you off the Cisco supply, but it can still trip. Okay, so there's totally disconnect the ACB. Okay, there's three bars in the ACB. When you turn, you have to turn like that. Okay, so you slowly go to fully energize, test, disconnect fully from Cisco. Okay, totally disconnect. That means disconnect means not only from Cisco, you totally disconnect the ACB. That means the ACB is not in the circuit anymore. Okay, so there's three things there. Okay, so you is fully connected, test, totally disconnect the ACB. Totally disconnect means you can pull out the whole ACB. Okay, that's what they do. In the servicing of ACB, they pull out the whole ACB and cuci, but don't ever clean the contact points. Okay, because contact point got some chemical there. Okay, so you don't clean that point. Okay, why? Because those chemicals are necessary. You see, the contact point look like this, right? But if you look at microscope, you see the contact point look like 2 points, but if you look at microscope, there's gap in between. In the gap in between, there be arcing, lightning. Okay, so what they do is they put a chemical there, such that the gap is filled up, conductive chemical. So that's why normally they don't want to sell you the chemical. I already try. Like ABB is a famous people who make this breakers. They don't want to sell you. They say just buy. Okay, buy new one. Okay, ABB like that lah. Yeah, 20,000 only, 30,000, 40,000, just buy new one lah. Yeah, that's how they talk. I deal with them before. Okay, but the choice in Sarawak mostly ABB or Siemens, the good one lah. Okay, because you must know these companies also lah. If you get cheated. And GE is number 1 in electrical world. Number 2 is Siemens. Number 3 is ABB. Number 4 Schneider. If Abdul Razak, you're dealing with a lot of this kind of thing, you buy from this company, you're safe lah. You can relax. Okay. If you buy alang-alang out of this list, you might have a fire and then you find out, oh yeah, because I buy from the wrong company. Okay. You stick to this company, but why? These people are 150 years experience. So if they sell something and it doesn't work, they will be shy. Okay, malu. Okay, but the companies down here, they sell you sometimes more expensive, and it doesn't work, they disappear already. You want to call it, hey, I want to complain. The company doesn't exist anymore. I've seen this happen in Syrian Hospital. One of the search arrestor device they bought for 12,000. Schneider selling for only about, that time is only about maybe 300 ringgit. Schneider world number 4. World number 4 company selling about 300 and they bought for 12,000, which is somewhere down the list. How can? There's no way these people here down here can compete if these people have all the top scientists of the world. Okay, so that's why if you stick to these few companies, you'll be safe lah. Okay, even China is the biggest greed in the world right now. China is focused on these 2 companies only. Sorry, not GE. These 2. China is focused on these 2. Okay. So normally from Chin is very good. Chin, but they don't sell big breakers. As far as I know, they don't sell big breakers. As far as I know, Chin don't sell ACBs. I've never seen it lah. But their contractors are very good. Okay, the Chin contractors like this one. Like this is chin. You can see chin here. It's very high quality. I'm very happy with this brand. Okay, but I haven't seen them making the big ones, and I think I won't trust. I know Cisco don't trust. Cisco only use this two. Cisco only use this two. So, okay, they don't use this also. Basically, it's like this lah. Okay. Uh, uh, okay. So Cisco only use this two. G is a USA one. So China don't use USA one. They only use this two. Okay. These are France. Very difference in quality when you buy Schneider. You see, one of the biggest problem in electrical is you don't tighten the screw properly. Fires can happen because you don't tighten the wire properly. There'll be arcing. After a while, you start fire. Okay. The Schneider one, see, I use a long screwdriver because the longer screwdriver you can get more torque. And plus that I use my whole body to turn. I'm not alang when I do this kind of thing. I tighten all the way. Okay. But if I get an ordinary brand, even my hand can break it. Schneider, I can use my whole body weight also, it won't break. Okay. So it's a very big difference in quality. Okay. So for me, my own project, I only use Schneider. And Schneider also, there is false Schneider. So in Kuching, I know where to get, because Kuching has a Schneider office direct from France. Okay. So I went to the Schneider office. I said, I want to buy from you. They said, no. I want to support my supplier. So who is supplier? He gave me a list. So one of the lists is Crown Engineering. So I get all my things from Crown. Most of my project I buy from Crown. Okay, Crown is in Pedungan there. Okay. So you must know in your town who is the supplier of the original. Okay. So Schneider is number 4, but they're pretty good lah. Okay. Okay. Fuji is also good. Fuji, Japan. Japan is very strong in power lah. Okay. Japan is very strong in power. Okay. Fuji. I asked one Cisco guy why they trust Fuji. He told me that during World War II, the Japan and the German were friends. So there are a lot of technology transfer between Siemens and Fuji. Okay, so that's why Fuji is very high quality. Japan quality good lah. I mean, they're very strong in quality lah. Okay. Okay. So I haven't fully explained this one. So okay. So what you want to do, you off the Cisco incoming, and then you provide your own current. Okay. How do you know how much current? You can see from the this one. This one has a CT ratio. Okay. So the CT has a ratio called like this. In fact, you must know that CT got 2 numbers. Okay. Okay. They will come on exam also. Yeah. They ask you a practical exam, they're going to ask you to read this one. So normally it's like 15 VA. This is a power rating. You see, transformers, you buy a bulb is watt. Transformer is in VA. Okay. And then capacitor is in war. Okay, so transformers and what else? Bulbs. Okay. So for bulbs, you go to shop, you ask how many watt, they ask you how many watt you want, right? Transformer, they ask you how many VA you want. Capacitor, they ask you how many Y you want. Okay. So actually, if you know one of these, you can use a triangle to calculate the rest. Okay. The Pythagoras theorem. You know this, you have, because there are four numbers. The triangle has three sides plus the angle. So there are four numbers. As long as you know two, you can calculate the rest. Okay. Okay. So the triangle has this. Okay. So this is how it works. Okay. You got a VA, you got a watt and a war. As any two you know, you can calculate the rest using this particular theorem. Okay. So, okay. So what you do in the injection test is, okay, you, if like just now I say your CT ratio is 200/5, you must put 200 and make sure it doesn't trip. If trip, something wrong because it's not supposed to trip at 200. Okay, 200 plus 5%, it should trip. Okay, so let me show you. Okay, this is it. So you can see here, it will trip at 100%. That means it's 200. You see no tripping at 100%. Just now I said 200/5, right? So at 100%, that's 100%. It's not, it doesn't trip. That's called carry point. Pick up is 5% above. 5% above, it should trip. Okay. So what you do is you inject 150%. That means like this. This is how you do the injection tester. You see. So you use a wise grip plier and join, and then you inject 150%, and then you inject 200%. Okay. So according to this graph, at 100, let me see how. Okay. At 150%, you look at this one, this graph. It should trip at this is 150%. 150%, it should trip here. Okay, it should trip here at 7.5 amps. This is 7.5 amps. Okay, and then at 200%, it must trip at 10 amps. Oh, sorry, what am I doing here? Let's see properly. Oh, that's 18 amps. Okay, so at 150%, it should trip at 18 amps. This writing here is wrong. This writing here is wrong. 100% is 18 amps. Oh, 150. Oh, this one is wrong here. No, this one is no trip. That's wrong. Sorry. No trip. Okay. And then 150%, you must trip at 18 amps. Yeah, sorry, this one is wrong. Okay. Okay. And then at 200%, it must trip at, you can see here, 10 amp. 200% is 10 amp. Okay. Oh, this is wrong. I don't know. 5 amp. 150% is 150% is 5 plus 7.5. 7.5. Because the output, you see, this is the output from the terminal. Okay, and 200 is 10 amps. This is correct now. Okay. Okay. So these numbers here is I think I get rid of this one. Sorry. Okay. This is correct. Confusing. Just get rid of all that. Okay. So at 100%, it should be no trip. At 18 amp, according to this graph, you see, at 150%, it must be 18 amp. That means the current coming out of the OC is 18 amp. Okay. Sorry. The current coming out of the CT is 18 amp. And at 200%, the current coming out is 10 amps. See, here is 10 amps. 10 amps. It's 10 amp, 18 amp. Okay. Sorry for the confusion. So let me repeat again. You see, when you inject like this, if you inject 100 amp, that means 100% of your CT incoming. CT incoming is say 200/5. You put 200. That means 100% lah. If you inject 200 amp, it should not trip. Make it 100 lah. Make it easy. 100. Okay. Make it 100 amp. That means your CT ratio is 100/5. Okay. 100/5. Okay. So I cancel it from 200/5 to 100/5. Make it easy. Okay. So that means this is written on the CT. It's 100/5. That means when you put 100 at the bar, 5 amp come out at the terminal. Okay. So 100% means 100. 150 means 150 amps. 200 means 200 amps. Okay. So when you inject like this, using this equipment, which is the 20,000 I told you, okay, I'm not surprised if ABM one is like 400,000, okay, because mega brand, okay. So you inject, because this will generate the amps. It uses a big CT to generate the amps, okay. So if it is according to this spec, at 100%, that means 100 amps, it should not trip. If it trips, something wrong, okay. That means fail the test already. 150%, according to this graph is given by the OC company, the company that made OC. But most of the factories, they don't have this one, Sudah hilang, okay? So what you do is you go to internet and type that part number. And there's this graph inside the manual, okay, the data sheet. So if you put 100%, that means 100 amp, it should not trip. If you trip, something's wrong. That means your injection test failed. Okay. You inject 150%, it must be 18 amp according to this graph. It's 18 because different OC got different graph. Okay. According to this graph is 18 amps. Okay. And then 200%, which is 200 amps, according to this graph, it is 10 amp. Okay. Okay. So to do the test, you must tune this one to 1. You see this TM here, you must tune to 1. And then do the test. And after you finish the test, you must tune back to 0.5. Okay? You must always tune back to 0.5. Okay? Only for testing, you tune to 1. That's why we use the 1 here. You see? This graph got so many graphs. This is 1. When you tune to 1, you use this graph. In normal case, it is 0.5. Okay? Okay. Yeah, in normal case, it's this graph, 0.5. Okay? Only for testing, you tune to this one. And how do you tune? You just use this one to select. Normally, it's 0.5. So you tune to 1 for testing. After testing, you must turn it back to 0.5. Okay? So you get a picture. So that's how you describe the test. You must draw this one. You must draw this for your exam. So you just draw a machine like this, and I draw in block diagram. Okay. The wire turn around this one enough, and the amp will be created. Okay. So what this one do is low voltage, only 240 volt genset, produce 240 volt supply, but it step down the voltage so much that the amp is very high. Okay. So I've myself touched this one. 168 amps, You know the limit for human to die is 1 amp. Okay. But this 168 amp, I touch it. Why I can touch? Because the volt is only 2 volts. I told you earlier in the class that you need 40 volt to go inside your human skin. This one only 2 volts, so it cannot go inside my skin. It's hot. The bar is hot. Heat is there, but I still touch it at 168 amps. Okay. Okay, so this is the injection test you need to explain for your exam. You just draw a simple genset and then current controller, and then you just draw these wires like this. You can take print screen of this Okay. Okay, and then you just describe this one a bit. You don't have to draw a graph you say according to the graph, 100% no trip, and then 150 maybe you can memorize 18 amp. 200% 10 amp. That's it. That's the answer for this question. Okay. So this very frequently come out, this permanent injection test, because it's a requirement by law to do this. And then you as a judgment who pass judgment must know how this thing works. If not, you call people to do this one. You cannot do yourself. Judgment are not capable of doing this one. You need to be a competent engineer approved by AIU to do this one. Okay, but you are judgment who call the person to do this one. You must know what they're doing. Okay, that's why I always come on an exam. Okay, and why you need to do this, you must know. At least you can put that in your exam paper also. The reason is to confirm that this whole system is working. Because if it doesn't work, then your building will burn. Okay, so that's the whole purpose of doing this injection test. Okay, by law it needs to be done once in 2 years. Okay, so you can call some people. Most people call JK. JK is a famous one. Like my UTS, my university, they call JK. And then maybe you can call me, but mine will be, the certificate is from Abang Effendi. I mean, I put myself did the test, and then Abang Effendi approved it lah. That's how it is. Okay. Abang Effendi is a Teli Kanyalang. Okay. By the way, Abang Effendi is a Chief Minister's brother. No, first cousin or something like that. Yeah, first cousin. Okay. Okay, so you must know this one lah. Maybe take print screen of this. Take print screen. of this, because this is a physical, this is the schematic. Okay. And then print screen of this lah. Okay, so this three print screen, and this one you don't have to draw, but at least you can describe a bit lah. This is a big question lah, like eight marks question, so you must be able to explain this one. I don't know how much they charge the injection testers, but you must be able to explain it lah. I think 450. One time they call for testing is about 450 ringgit. Okay, last I heard lah, 150 ringgit to do a test. Okay. Okay, so this three, you take print screen of this lah. 1, 2, 3. Okay lah, that's it. Already 4. So continue next week lah. Okay. Okay. Yeah. Jane, okay, see you next week. Okay. Oh yeah, regulation. Just now, sorry. Abang Razak, sorry, Razak, you asked for regulation. Let me give you the law. I show you the law. Wait, the law. Wait. Okay, let me show you the law. Okay, you can take print screen of this. You see, authorized to test. This is the law. This is the wording of the law. Okay, at least once every 5 years is this one, but injection test is this one. At least once every 2 years. Most people don't follow this one. This is the ATT. I think majority of installation don't test once in 5 years lah. Okay, but this one they really enforce lah. Okay, this one this is the wording of the law, the Sarawak electrical law. Okay, so it's written here once every 2 years. You can take print screen of this lah. Okay. So you see, the people who can do this are who pass this one. I pass this one, they don't give me. So it's not just passing not enough, like you need some political power also. Okay. That's how it works lah. Okay. 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 Okay, so see you next week lah.